Start recording. And I might even remember to turn it off at the end. Okay, so here we go. Well, actually, there's maybe 10 seconds left according to my computer, so we'll wait. Just there it goes, 9 a.m. So the first thing I want to do is bring up the. Remember, we're really looking at how planning affects what's called fair housing, and understanding fair housing is an important issue. A lot of what we do in planning really does cause problems for people. And sometimes it's with the greatest intentions and just not thinking about the problems that might come up. And sometimes it's more blatant. So what I want to do is show you, this is one of the more blatant ones. Fair housing has been thought of being an issue for many years, and it's been a little over 50 years since they tried to codify some stuff into law that was just like obvious. But let's take a look and see what just happened a week ago. Okay, HUD was developed from the fair housing process to protect that's their job, is to protect the rights of residents in housing. And they haven't always done a great job. Sometimes they have done a great job. It's always been a difficult job because as anything, when data is kind of odd, it can be a problem. But HUD, in response to a Supreme Court ruling, they actually just violated the Supreme Court ruling. They just went right against it from 2015. And you can read this and look at it. And it's important that you be familiar with things and you read. Now, I will say Bloomberg is a little bit on the political side. As you know, the guy who owns Bloomberg Reports was running for president. He's all about the money, but from one side. But I always suggest you look at where the money goes and where the money is following and where the money is coming from. And I'll let you do your own research on this. But this is a pretty bad deal that's happening here. That's my own personal statement and my own personal belief that when I look at this is counter to fair housing. I believe it's our government's job to enforce fair housing and let companies try to justify what they're doing rather than the other way around. So anyway, here's an interesting one. You'll learn more about that on the 29th. We're going to have our first seminar. I believe it's going to be Diane Carlson. She's a professor at Folsom Lake College, and she's done a lot of research on fair housing, and she's going to bring up some of the history for you so that you'll have something that you can sink your teeth into when we get some of our other people. Now, we have got two others lined up. I think one is on the 14th of October and one is on the 26th of October or 24th, somewhere around there. One of these is a person who works for the mayor's office of New York. They're very strong on fair housing, but it causes a lot of problems. There's nothing that always works. And so this guy is working on their fair housing programs in New York. And so I thought that would be an ideal kind of second view. It's more urban than what our fair housing always is. The other one is Jesus, who is working with the South Franklin Community District. So he's local. He's with the planning agencies and very strong advocate for local planning that actually works. So he's into doing the nuts and bolts that we like to hear about, but he does it at a pretty powerful high level. So those two are coming up. And then we have one more that I think is being based out of Davis. So we've got 3-4 seminars coming up. The first one's going to be on the 29th. I encourage you to come. It's going to be during class and get some real background information. The more information that you've got, the more that you can decide for yourself what right action is when you do planning. What I've seen is most planning is about money. That's really what it's for. Money makes our world go round. But it depends on who the money is for when you're talking about planning and what you believe your planning department should be looking at. So there's a few people that have posted some nice comments into the articles. You can go look at those. I've posted some of those. If you want to do some more posting, that would be good. But these are important things to think about. You have a client always. You have a client, but you also have a responsibility to your community, and that's very, very important. So I grew up not from Hawaii, but in a judo system that came from Hawaii, and everything was couched in a Hawaiian term called kokua, which means kind, generous, helpful, and useful to your family and community. And so I kind of have been inculcated in that. Not everybody thinks that that's a good way to go. And so that's why our world is so interesting and wonderful. But that'll be kind of cool to look at. And certainly go take a look at this article and read it in depth, and then maybe bring some more information to bear. Okay, so these are our lecture topics. There's a full set of lecture topics. We're in a new module now. This module is on topo drawings. We did plot plan drawings, and I realized some of the site plans and plot plans had topo information on them. Topo drawings are a type of plot plan or site plan. And we're going to look at them a little bit more careful. And we're really going to be talking about right now land planning calculations by area. Because your topo drawings are really where you're putting your building pad in and finding out where your building pad goes and the elevation and looking at drainage and things like that. And once your building pad is in, then all sorts of other planning options come. So we're going to look at these ones first, and then we're going to review the section drawings. And we're going to look at these drawings in general, and then during the lab, I'm going to give you things that you could do. So for this assignment, you can see, I'm going to click on it now. I've actually got it over here. Okay, if you click on this See Aries Estates drawing right here that you see right there, you'll see this. Okay, and you know what? I think I'm going to get a Jamboard started. That's not where I want to go to do it. I've got to come here, and then I need to come here, And here, there we go. Got a Jamboard. I'll start a new one for this class. If you guys haven't used this, it's a pretty good little tool. So it allows me to kind of play around a little bit here. So now I've got this cool drawing that I can scribble on and you can see stuff. So what you see here is this is from DT 302, right? Most of you have drawn this. Many of you have drawn this. If you haven't, I've given you an AutoCAD template of the lot lines. But this is very typical of a little development drawing. So there's some sort of a piece of property that's being subdivided into lot 1, 2, 3, 4, 5, 6, 7, 8, 9. What you don't have on this drawing is the text. Okay, if you have a version with all of the lot dimensions, you can use it. You can get it if you use Revit, it just pops out, or you can use your property boxes to get those dimensions. But most of all, you can see that all the corners of each lot have an elevation. And so sometimes we think of these lots as being sort of flat, but this thing, you can see here's the high point, and it slopes down this way. So we know unless we grade this, the water is all going to go this way. It's going to continue to go this way. This one's going to go more straight this way. This one's going to go this way and here. This one all coming toward the middle, which means that your storm drain is all going to be in here. None of this lot is going to go into our neighbors. Now, when they develop these outside areas, you'll need some sort of planning that knows whether the water is supposed to go this way or if the water is supposed to go the other way, away from the lot line. So these are planning department type issues that when you do your drainage plan, you would need to know. If the water from your neighboring properties is also going to go this way, like if this is in the low point of a major high area, then you're going to need some sort of a drainage trenching along here, or tons of water is going to come down and impinge on your building pads. So these are those thought processes that you go through. And landscape architects will be heavily involved in this, but just plain old architectural and civil engineering and planning does it. So Benjamin says, yeah, his area is kind of crummy, huh? That's a bummer. Is it all going to your house, or is it your property, or is it going somewhere else? Kind of a, yeah. So I owned a building at one time that was a preschool, and I don't know how it happened, but everything drained to a puddle right in front of the entryway to the building. And it was crazy. Like this was 2 to 3 feet lower, the entryway. Now the building itself was up, but you couldn't get, so we had to install a pump and a deep well and all sorts of stuff because it was actually lower than the street level. I have no clue how that happened, but it works. We have a pump, had a pump. So, okay. So there's some information that you get from this, and you should be able to create this. I gave you the lot lines already. Yeah, see, a French drain is probably not quite enough. You may need a pump, which means that French drain is there. It's going to a pipe. But if the pipe doesn't have the outlet to be able to really pump it out, you may need a little bit of a deep well pump there. They're not too expensive. However, what happens during the heaviest rainstorms? Your power goes out. So you need some sort of a backup system to power your pump. Pumps are really good while there's power. Or you need a hand bilge pump or something like that out and kids to go out and run it. Okay, so you should be able to draw this. You don't have to have this type of marker. You can use any kind of marker at all the changes of directions. But here's the important part. From this, each lot is given an area. And I've identified the zone. Now, I don't need to do this on each and every one. I could make that a note down here. All lots zoned R2. But R2 means something, right? Here's the number of square feet. Here's the R2. And this will tell you what you can put on this lot. Can you put a duplex? Can you put a large single family? What can you put on here? Okay? And so this is the area in square feet. It might be nice to change it to acres. I've got this. I've got a north arrow. And I have something that I can scale off of here if I need to. Notice that my lot lines are easy to see. And my elevation marks are all easy to see. Now, I would say that these elevation numbers should be moved outside. That's our standard, if possible. This should be moved down to here, outside. This should be moved down to here, outside. This one's impossible. You can't do anything with it. This one should be moved outside. So I did notice that some of you made as close to an exact duplicate of what you were provided as the sample. So Benjamin has a good question, and I'll answer that in just a moment. And you can look that up in that planning document I gave you, and the answer is there. And it's kind of cool. And so I'll answer that in just a moment. So please meet the standard if you can. Okay, you will do better to recognize that this number belongs on the outside than not. And really, these should be in line with either a tick mark or some, it just looks better. It just looks better. Now, some people line them all up in a line out here. That's pretty cool too. If there's not a lot of writing going on, that can be pretty useful too. Okay, this is identifying sort of the 0 point for this project. Okay, there's something that you know where it is, and that manhole is not going to move very far. So now it doesn't really show this, but you know that it's due east to wherever the lot line is between these. So it's not the greatest drawing I've ever seen. Really would have been better to come off of this point or this point down here.
Do we have to indicate this 40-foot distance, or do we just put a space out there, a spot out there, and say handful?
Yeah, no, this 40 foot is important, but you don't have to put it to there. If you want to measure it down to this point, you can. Okay, but it really should be to one of the survey points. Okay. But that's locating where this is so that this is all cool, but somehow there's going to be a surveyor that's going to put a stake right there or their rod, and then they're going to start measuring all these out.
Does it have to be 40 feet?
Well, yeah.
Okay.
Okay, but that's easy to do. You just draw a line 40 feet long. Okay, but I didn't really locate it for you. So you can kind of put it anywhere. There's not enough information to get this drawing all the way done. Okay. So there's this one. So now Benjamin says corner lots are often larger. Okay, there's few reasons for that. You'll look in the standards, corner lots have a larger offset in both directions, and they're usually have a larger minimum lot size. So if all these other lots had been made at the minimum, these corner lots would automatically be larger because corner lots are, instead of like a minimum 65 feet, they're a minimum 75 feet. And that's because there's an additional maximum offset. Like on the sides, usually there's an offset of 4 feet and 4 feet so that you have the fire lane of 8 feet. Now, people often put air conditioners in the way. You're not supposed to. And the planning commissions will look at that to make sure that you always have a fire access to the back. Lots and lots and lots of rules to go into, which is why I want you guys good at reading codes. There's no way I can go over the codes. So I sort of throw out little bits and hope that you'll go, okay, oh, there's a fire code. Oh my gosh, I got to read the fire code before I get work somewhere. And I got to read this code and I got to read that code or know where this code and that code is. But normally these corner lots are larger because there is an extra kind of access or easement where there's another road going on. So corner lots usually have additional offset, and so they make the lot bigger. And that is in that use thing when you look at the sizes. So there's one that's of interest. Now notice that these are written pretty large. Okay, they need to be easily identified. So like if these are 3/32 maybe, these will be a 1/4 inch. Because that's really what you're just trying to do. You're just trying to identify each lot. Okay, and then over here, normally I get rid of this line or this gap. Usually there with a gap. You'll notice that I've got my scale on there. Okay, any questions about this one? And I'll go on to the next one. We'll talk about the calculations a little bit. Okay, let me make another Jamboard then. Of these, this is your favorite stuff. I know you guys all love to calculate. I love to calculate, actually. And I don't usually make these things available to you, but if you want to, I can make these Jamboards available. What is this? This is 350 on 915. Oops. Okay, so I've got a whole bunch of interesting here we go, calculations. Here we go. So here's my first set of calculations. And so I reproduced this thing. And then I did some calculations. Okay. Now, Revit allows me to do these calculations on my own. Inside of Revit, you can actually set up your schedule with calculated fields. And I'm going to show you how to do that in the lab. So Renolfo says, can you make your own north symbol? Yes, you are allowed to make your own north symbol. And sorry about the squeaky chair that's coming through everything, but I needed my comfy chair today. And so there's built area. Built area is really important. Sometimes they call it FAR, SAR, BA, BAR, built area rentable. And this is ground area. This is area of the ground. And notice includes parking. So if I've got a 20 by 30 driveway, that's 600, that's 20 times 30 is somewhere around 600. That's 600 square feet taken up, and then probably 400 square feet. This is still a lot of area. That's a big built area, but that's the maximum you can put on here. And that would also that's sort of like non-permeable area. So if you have paved areas on the side of the house, at the back of the house, swimming pool, that's all built area. So a lot of times I call that non-permeable area. Now, if you're, and this is for residential, right? So you can see that this might be, since it's R2, and I can put 2 units on this place, that that I could put a good size duplex on there, right? I mean, I could work these into duplexes, little townhouses, things like that. There's lots of ways you can go about doing this, but this is key information for the architect. The architect is going to need that to be able to do that. And Laura, I'm getting a little feedback from yours. Could you mute yours? Thank you. Hard to figure out what all is muted and not muted on these sometimes. So this is critical in the architect's ideas of what's going to go into this area. And critical to that is what type of owner is going to be in this area. Is it somebody who's going to be building to rent, to sell duplexes, where often on a duplex, one person owns both and rents one out? Lots of different ways. So this is key information. And I put this in here just because if I'm going to make a square building pad, how big will it be? It just gives me an idea. Now, who's going to just make a square building pad? Well, you're going to show it maybe on your drawings to get an idea of what the drainage might look like and what the cut and fill might look like. But these are initial planning documents, and the architect is going to come back and really work on it. Is it going to be L-shaped, T-shaped, H-shaped, U-shaped, rectangular, square? what's this really going to look like, and where will there be porch and driveway and some of these other things. Okay, so this one's a key thing, and you just should be able to calculate this. Now, I'm going to let you either look this up. I looked it up in the code, in that code I gave you. I just went to square feet, and I started, Control F, and went through the 515 per acre or per square foot things, and I found it. Or you can just do a calculation. These all should be about the same ratio. How do you do that? Ratios are gazintas. This number goes into that. This number goes into that. This number goes into that. So if I want to find what this number ought to be, I do a gazinta. 4011 gazinta 6686. Oh, that's pretty close to 60%. Let's try this next one. Where's my clear? 3519 divided by 5865. Oh, pretty close to 0.6. Let's try the next one. 3035. So you can get a lot of information just by reading the numbers. 0.6. So in this area, you can see that the R2 call out says that your maximum built area can be 60% of the lot. Likewise, I could put down that I want 40% open area. Now that's actually kind of crummy. That's a lot of concrete. And you might be envisioning this development as having more nature, more open space and land and trees. And you might put small units on and have a lot of open area. What developers will want to do that? What type of developer might want to do that? A sustainable developer. Yeah, somebody who's really into that. Usually, that's a developer that is also going to live on this area themselves. So, want to make sure it looks a certain way and is a certain way to be able to do that. Okay, most developers are in the business to make some money, and you make money per square foot of built area. That's really how normally you make money, per square foot of built area. The other type of developer might be the type like Dave Welch, who understands that there can be money made out of renting out workshop space. So they might put a small building pad on and leave room for outbuildings. So now, and this is being not pushed but made easier by the state government now, that is allowing infill up to your maximum built area by putting in up to 2 granny flats per location, and that's what that's what they were having a cow about in that one. Was it Santa Monica? Now I don't remember where that article I posted. Okay, so now this says, if I were to put in a square pad, about how big would it be? So that's the square root function, right? So let's go 4011 square root, about 63 feet on the side. So this is the arithmetic you should be comfortable with. How do you take an area and make it into a square? Square root. And it's just on just about every basic calculator on your phone, on your computer, whatever. This is just a gazinta, a ratio. What's the percent? So if you know your percent here, if you know a percent number, you can just multiply this area times the percent, 0.6, to get this, and then you can take the square root to get your final number over here. So that's how you develop this. Now, of course, I've given it to you, and so you can just copy it, but you will have a hard time on the skill demonstration if you don't understand how to do this. And remember, you have to pass the skill demonstration to pass the course. So yes, you can just copy this, but that skill demonstration will come up in about 4 weeks, and you will need to make a table. Okay? So understand these. This is based on percent. I'll give you a percent. I may even give you a standard to go look the percent up in. Okay? It might be in a standard that I made up and give you, may not. Calculate these things. Maximum built area, square foot, and how much pad area is that. And then over here, I changed it a little bit. I said, I wonder what that is. Wonder how I came up with that. Well, let's see. Let's see if it's gazinta this number. 1890 divided by 4011. It's about 47%. So let's multiply that by 3337. 73. Nope, that's not how it went. So this one might be a little bit tougher for you to figure out. I can go into the Revit and find out what I did there. And look, these are all about the same. And I can tell you what I did is I took away some. Now, I don't know why that one's smaller than these. That one looks a little bit weird to me because these numbers are all smaller and these are all bigger. That might have been before I started rounding. But we need to take a look at some of these. I'll go back and figure out what my calculation was there. And then how would I find out a perimeter on here? I have to look and see what I did with this one. that's what I did. Right, so I took this as a square, and then 4 times each side. Okay? So this is just arithmetic. It's not even math. It's just arithmetic. Find how big, how do you make that into a square? It's the square root. Square root. Very quick and easy. What's the perimeter of a square? It's 4 times the side. So that's your building pad schedule. So this is the max. And that's the building pad that I decided to put on each one. Now here comes the key part. Once I've got that, now we're really into the land planning, the civil development portion of it. That's all cool. How do I bring my utilities to it? Remember, in the utility plan, there was gas, there was sanitary drain, there was cold water, there was some electricity. Well, when you drive by a small development, you'll see, I mean, they have to get that all under the road before they start grading each site and building the pad, and you'll see them sticking up out of the ground out of pipes and stuff like that. So how do you know how much to put underground? Well, here's my electrical amps. So let's see if there's some sort of a little basic calculation I can make. And if I come over here, there's a kilovolts per square foot, kilovolt amps per square foot. And so multiply it by the whole number of square foot and all sorts of stuff. So I did some calculation around that. And I came up and I actually used eQuest. I used, for those of you who have done DT310, I used eQuest, and I think I came up with a ratio. So here's my square foot of my place. And I don't know which square foot I used, but I think it was this one. So let's go 130 amps divided by 6686.02. So if I multiply this by 0.02, let's see if they're all sort of like that. 8434, whoops, 170, 8434.02. So if you take this square feet times 0.02, you get that number. That's how many electric amps there are. Now those amps are at 220 volt AC. And you'll learn more about that in DT330. But this is really important. If I were to add all those up, I'd get a pretty big number. 130 plus 110 plus 170 plus 120 plus 100 plus 140 plus It's like over 1,000 amps. Now, that's going to take a big, big, big wire. Okay, especially if that big, big, big wire was carrying 1,000 amps at 220 volts. So if I don't want a huge wire, that wire would be like a foot across, foot in diameter. Big old wire to carry 1,000 amps. Okay, especially if it's, hundreds of feet long. So just like anything, I'd rather not put, and that's probably a cable that big. It's probably going to cost me 10 or 15 bucks a foot. So if I want to get that cable down in size, I have to use less amps. Somebody tell me, if I've got 220 volt at 1,000 amps, how do I get that to be 500 amps? Anybody know? All you landscapers should know this. For sure. Because you learn how to run wire. Okay. Laura, how do I get that to be 500 amps? You can use your mic or you can just write it in there.
I don't know. I just know that we need to know that.
Oh, okay. Okay.
Because you're running
So you double the volts. Volts times amps is the amount of power, and wires are rated by amps, but you're actually trying to deliver power. So if I double the volts, 440, then I can come in. So if I run 443 phase to my building, or even 440, what they call two phase, where there's a neutral, then I can go between the two legs to get my 220, or a leg and the neutral to get my 110. So they're going to run 440 up to your property, up to your house, and then in your box or somewhere near your house, they're going to knock it down to the 220. They'll actually probably run 600 volts. That's what they usually bring off the power poles. And then they'll transform it. You see transformers, boxes sitting all over the place in neighborhoods, right? You go, oh, what's that box doing there? Sometimes they're underground, sometimes they're above ground. Those boxes get the high voltage somewhere near your house, so you don't have to do big old honking wires. It's not such a big wire to run 130 volts. So from that transformer somewhere around your house, they run your 130 volts to your house. So if you're running wire in the backyard and you need 12 volts, you might run 24 volts out there, use a smaller wire, and just have a little transformer at your point of use, especially for things like solenoids and stuff like that, where wire costs money. And if you're running solenoids all over the place and you got hundreds of feet of wire, you don't want to be running hundreds of feet of too big wire. You want to be running hundreds of feet of small wire.
Is that the way it's typically done? You have a transformer put in?
Well, it sort of depends. I mean, it's so different because who knows what they're putting. What do most of the 24 volt or 12 volt things running? Solenoids, right? That are either running a valve or a water line or a switch, or maybe it's a 24 volt light or a 12. It so much depends on what you chose to put out there. But then when you're speccing your job, you want to run small wire if you can. It's less expensive. And if you're talking the difference of 15, 20 cents a foot, or even 5 cents a foot, and you're running 300 or 400 feet of wire, well, that's 15 or 20 bucks in your pocket each time you do that. So think about those things. If you double the volts, you cut the amps in half, which usually cuts the wire size in half, or cuts the wire size down. So this is all about how big is the electrical box on the building, and this total is how big is the wire that's running underground to your distribution transformer in your area. So the next thing on your utility is your cold water supply fixture units. That's not saying FU. Those are fixture units. And a fixture unit is how much comes out of a fixture, a sink, a hose bib, a washing machine. How much water comes out when you have rated pressure on that unit. So most units are rated for low pressure, 22.5 psi. And many of them actually now have tiny little pressure regulators so you don't use more water, right? If it's rated for 22.5 psi and you hit it with 50, you're going to get more water coming out. Unless there's a little pressure regulator that keeps the water at 22.5. So most devices now have little pressure regulators on. All your shower heads and sinks and faucets and things like that, which is a good thing. We don't need to waste water. Even for landscapers, so many of the actual pop-up heads have the pressure reducing valve right on the head. So you're not wasting water. You know exactly how much water is going to come out of that thing. Because there's a valve that keeps the pressure right there. That's a cool thing. So, at rated pressure, how much water comes out of a fixture, and then when all your fixtures are running at once in a building, how much water is going to get used. And that you can sort of do by square feet. And part of this is square feet of permeable, and part is square feet unpermeable, and sort of like how many bathrooms are there likely to be, and how many sinks are there likely to be, and how many spigots are there likely to be. But this is also probably some sort of a ratio. So let's look and see. 35 divided by 6686. It's about 0.005, it looks like. What's 40 divided by 8434? 0.005. Okay. So this is, and I estimated that out. I take, again, eQuest and look at the amount of water that's likely to be used per square foot, or I go into this chart right here. A bathtub is likely to use 4 fixture units. A dishwasher, 1.5. A hose bib, 2.5. A laundry, it doesn't say, that's interesting. A lavatory, what? So you can sort of kind of figure out about how much you're going to use in a typical building. So you've got a link to that. So again, you want to find out how much water is going to be used, and you add up all these fixture units, and it tells you how big the pipe that's going down the middle of the street needs to be able to handle that much water all running at once. Your standard is based on everything being open fully at once. Now, there are a few things that you can do that says it's only likely that you're going to have 80% of the bathrooms flush at exactly the same time. Well, I did a job at a prison in Tennessee where the prisoners figured that out, and they all flushed at the same time, and they crashed their system, blamed it on my valve that started to water hammer. I had to go there, and it was one of the worst experiences of my life. Don't go to jail. Just don't go to jail. This was a medium penitentiary, and the guards were all, the guys had to clear the block that I could go into. They all had to stand far enough apart so their fingertips would barely touch when they were standing with their arms out. And they actually had to stand there the whole time with their arms straight out while I was in that building. And every now and then I'd hear the shotgun going off, which meant somebody had dropped their arms. Yeah, it was awful. It was a horrible place. Don't go to jail. Do everything you can to avoid going to jail. And that was a medium penitentiary. Oh my gosh. Anyway, so it can happen that everything flushes at once. The most common one they talk about is the Super Bowl, right? Come up to, the break or halftime or whatever. Whoosh, everybody flushes at the same time. So that's your supply, and then your sanitary drain is the same way.
Randy.
Yeah.
One more time clarifying. The cold water supply fixture units per lot. So that would be any hose bib, any shower head, any sink. So that would be 35 of those.
Yep.
A lot.
Yep.
Okay.
And then it's real interesting. The drain fixture units are different. Isn't that weird? The drain fixture units are a little bit different. And that's just because of the way that it goes gravity feed. And you would think what's coming out is going down, but it isn't. It's odd. How it hits the driveway is a little bit different. So your drain fixture units are a different ratio, but it's still a common ratio. Okay? So you can look at that ratio to find that for the drain. How much is going down the sewer? And of course, some of it, which is hose bibs, never goes down the sanitary drain, right? Sinks into the ground or goes into storm drain. So this tells you about how big the pipe coming out of your house and to the sanitary drain in the middle of the street has to be. Oh yeah, so Ben, I hope your friends. That's not a fun job, man. I can't imagine. Worst thing. Okay, and then there's gas, and you can see there's going to be another 0.003. So there's going to be another ratio. So this is just filling out a utility schedule that you're going to want to do. Okay? So that puts us all at the end of lecture. How did I do? I did pretty well.
Wait, what was the gas? Go back to the gas.
cubic feet per hour of natural gas. So that would be like 1,400 divided by 6686. Probably about 0.2. Cubic foot per hour, CFH.
Give an example of that.
Okay, so your gas runs things like your hot water heater, your furnace. Some people have a gas range on their in their kitchen. So it's the natural gas for heat, hot water, and cooking mostly. Okay, most hot water heaters around here are gas. Many, many, many furnaces are gas. So
that 1,400 is that's what it's fit for. That's what they expect to be used in that lot. What does that mean?
That's cubic foot per hour. These are all sort of sizing things. It says this can happen at any one time. At any one time, you might pull 130 amps. At any one time, you might have 35 fixture units, which becomes 35 gallons per minute. At any one time, you might be draining 20. At any one time, you might be pulling 1,400 cubic feet per hour of natural gas. So as you design your utility for the lot, your pipes have to be big enough and your wires have to be big enough to do that safely. And in the middle of the street, that's getting all of these things added up together, your big wire that goes down the middle of the street underground that brings you your electricity has to be big enough to do all of that at once if everybody turns on all their electrical at once. And your big pipe bringing you your cold water down the middle of the street has to be big enough so that you can supply water when everybody turns everything on all at once. That's just the requirement. And
so are there pipes that are rated for? Are they range like 1,400 to 1,000, 1,400, something like that?
So here's, for instance, a pipe friction loss chart. Okay, well, this one happens to be millimeters. But let's say you want 200 liters per second. Then you need at least a 30.8 or a 30.8 millimeter pipe. You could go down to a 5.18. Oh no, this is your velocity. So you would want a 178 millimeter pipe anywhere up to a 2.54. And this is your friction loss. So that has a lot of friction loss in a small pipe compared to a big pipe. So yeah, they have tables about how big a pipe should be compared to how much water is going through it. Let's see if I can find one.
You probably want that 254 pipe so you don't have that friction loss.
Yeah. Although that's more expensive, right? So here's like gallons per minute, 10 gallons per minute in a 1 1/4 pipe. Then you're going to, of this type and this type and this type, you're going to lose this much friction. So they have tables about all that. And that's what we do in DT 330. Your job in this class is to prepare the information based on your square feet so that somebody can start doing the detailed design. Okay? And, so on this one, in the middle of winter, when you've got your furnace running and everybody's cranking their hot water in their shower, and you've got, you're boiling up your tea and this and that, and so everything's running, you've got that going. Okay, you could be pulling that much gas, and you need a certain size pipe to get that gas. Now in California, they just raised the size of that gas line, by the way, out of the standard. They just raised the minimum. So if you put in a tankless water heater now, you're likely to have to replace your gas line too. Okay, so does that help, Natalia? Yeah, did you have to replace your gas line, Laura?
Yes, we did. We
Yeah.
we had it all done when we put our tankless in.
Yep. Okay, because it uses more quickly on demand than a hot water heater that just slowly, it has this big reservoir so it can heat it up slowly, so it can use the gas more slowly. Those tankless systems, whereas you're not losing energy all the time. Boy, when you need the energy, whap, you need a ton. So overall more efficient, but the energy flow rate is much higher. Okay, so Natalia, does that help you understand what these numbers are all about? It's figuring out what's got to happen.
I do understand the concept, but kind of lost in the calculation.
Okay, well, it's just a ratio. So it's this number divided by this. And then you just keep doing that. Ratios, 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 ratios. It's percents. This is a certain percent of this. And it's amazing that we can do these calculations that way. But that's how that you do that. Your house uses a certain amount of energy per square foot. And this is just how they calculate out. It works that way. Percent. Your house uses a certain amount of water, and it's a percent of the square foot. Now, your actual house could use less because you might be careful, but you can't design your building that way. You have to design your building to take care of a hog, because you never know who's going to use it and for what. It's just a percent. Divide this number by your area, and then just do that all the way down. Divide this number by the area and do it all the way down. And once you've got that first one, you've got them all.
Are we going to have a chance to practice on that? Where I'm still kind of lost.
Yep. Yep. You get to practice this in doing this. Like if you want to just copy this, well, then that's okay, but you won't get any. But you need to make this. This is for you to actually draw. So you want to draw this and then create these tables. And so I would do these either in Revit or in Excel. If you do it in AutoCAD, you're just going to put in an Excel spreadsheet, right? Or type in a table, but it's much easier to bring it in from a spreadsheet, which I can show you how to do. And I will show you how to do in just a moment. Okay? Divide a number by the total and get it. Okay? And I can make some exercises up for that. Fortunately, you've got 2 weeks to do this and about 4 weeks till the midterm. So that's good. Okay. So these are all good questions though, right? Now we're really into the guts of this thing. Any other questions about how to do this chart? Okay, I'm going to stop this recording then.